All right, let's talk about something really weird, a fascinating puzzle right at the heart of artificial intelligence. We've built these incredible machines that can do amazing things, but they have this strange problem, a kind of digital amnesia that's holding them back. So let's get right into it. This question, it seems so simple, right? But it points to one of the biggest challenges in AI today. Why is it that you can teach an AI to be a grandmaster at a game, but when you try to teach it something new, it's like it just wipes the slate clean? It forgets everything it knew before. To really get to the bottom of this, we've got to look at the huge difference between how we humans learn and how most AI models are trained. And trust me, they are two completely different worlds. I mean, the difference here is just night and day. When we learn, it's cumulative. We build on what we already know. It's like stacking Legos, right? Each new piece makes the tower of our knowledge stronger. But standard AI training, that's usually done in these isolated sessions. So to learn a new trick, the model basically just knocks over the entire Lego tower and starts building a new one from scratch. It just overwrites the old knowledge, which makes it incredibly prone to forgetting. And this isn't just some minor little bug. It has this amazingly dramatic name, catastrophic forgetting, and it is every bit as bad as it sounds. When a neural network gets trained to identify cats, and then you train it to identify dogs, it might become a world-class dog expert, but it can completely lose the ability to even recognize a cat. It's literally a sudden, task-induced amnesia. Okay, so forgetting an old task is one huge problem, but there's another one that's a little more subtle. What happens when it's not the task that changes, but the world itself changes all around the AI? Well, that's called concept drift. It's like the AI's knowledge is slowly going stale. Think about a sensor in a factory that's predicting when a machine might fail. Over time, that sensor might just get a little old and dusty, and the data it sends out starts to change. Or maybe in a wireless network, new kinds of interference pop up. The point is, the world doesn't sit still. And an AI that's only trained on a single snapshot of the past is just doomed to get less and less accurate over time. And the impact of this drift? Oh, it can be huge. In one study looking at a simulated IoT network, a standard AI model was doing just fine. Packet loss was a little over 6%. But then, researchers introduced some unexpected network interference, a classic case of concept drift. And bam! That packet loss number shot up to nearly 20%. The model's knowledge was suddenly dangerously out of date. And this data right here points straight to the solution. You see how the standard AI model just falls off a cliff when the world changes? But now look at the lifelong learning AI. Its packet loss is just 9.84%. That is remarkably close to the optimal baseline. That's the absolute best performance you could possibly get in the new conditions. This is the proof. There is a way to fight back against this AI amnesia. So, how do we build an AI that can actually remember its past and adapt to the future? Well, the answer is a really exciting approach called lifelong learning, and it's all about giving AI a persistent memory. Yup, the fix is this whole field called lifelong machine learning, or LML for short. The goal is to design systems that don't just learn in these isolated little bursts, but learn continuously. They accumulate knowledge over their entire lifetime of tasks, holding on to what's important from the past so they can learn new things way more effectively in the future. Now, you might have heard of something called transfer learning, and it's a great first step, but it's fundamentally different. Transfer learning is like taking a single photograph of knowledge from one area and applying it to another. It's a one-time snapshot. LML, on the other hand, is like hitting record on a video camera and just letting it run. It is always on, always accumulating new experiences and weaving them into what it already knows. This all sounds great in theory, but, how do you actually build an AI that remembers? It turns out researchers have developed some incredibly clever strategies to make this happen. At its absolute core, the entire challenge boils down to this: the stability-plasticity dilemma. An AI needs to be stable enough to protect the knowledge it already has, but it also has to be plastic, you could also say flexible, enough to learn new things. If you lean too far one way, it can't learn. Lean too far the other, and it can't remember. It's a really tough balancing act. So to solve this puzzle, researchers basically have three main tools in their toolbox. First is regularization, which is a fancy way of using math to protect the most important connections in the AI's brain from getting overwritten. Second is replay, where the AI actually revisits a small sample of old data while it's learning something new. And the third, and maybe the most exciting one, is to actually change the AI's physical architecture as it learns.
Let's dig into that last one because it is so fascinating. These architecture-based methods are a complete game changer. Instead of having one giant monolithic network, you have these things called modular networks. It's like decomposing the AI into a collection of smaller, specialist subnetworks or modules. Each module can become an expert in one very specific skill. Then, when a new problem comes along, the system learns how to combine these existing specialist modules in new ways. It's like having an endlessly powerful and flexible toolkit.
So, why does solving AI's amnesia problem matter so much? Because it unlocks a future where our technology is no longer static. It becomes truly adaptive.
I mean, we're talking about self-driving cars that don't just rely on the maps they were trained on, but continuously adapt to new road signs, construction zones, and crazy weather. We're talking about medical AI that gets smarter with every single new patient case it sees, robotic systems that can learn new physical skills right there on the job, and personal assistants that can actually grow and evolve with you over your entire life. Ultimately, this whole quest is about moving beyond just making our AI systems smarter. It's about making them wiser, more resilient, and way more capable of navigating the complexities of our ever-changing world. And that leaves us with a final thought to chew on. What new frontiers open up when the very tools we build can learn and remember right alongside us?